In this video, we'll examine VPC endpoints and how they can be used to securely connect to AWS public resources from within a VPC. VPC endpoints are used to allow private access to S3 and DynamoDB. So if I have services hosted within my VPC and I want to give them access to public services like S3 or DynamoDB, I don't necessarily want that traffic flowing over the internet. I don't want to have to create a VPN. I don't want to have to set up NAT. I want to just allow my internal VPC resources to communicate privately and securely to S3 and DynamoDB. And so what I can do is I can create a gateway type endpoint. These are available only for AWS services like S3 and DynamoDB. And these types of endpoints will add an entry to your route table that you select and will route traffic to the supported services through Amazon's private network. So for example, if an EC2 instance in a VPC needs to communicate with S3, there will be a route table entry for that subnet, and the traffic will be directed over that private connection instead of over the internet. So that's a gateway type endpoint. An interface type endpoint provides private connectivity to services powered by PrivateLink. Those services could be AWS services. They could be your own services. And it supports connectivity over Direct Connect. Okay, so in this slide, we see a basic diagram. We've got a VPC. Within that VPC, we've got a public network and we've got a private network. So we've got two different subnets. And for each of those subnets, we have network ACLs associated with them and route tables associated with those subnets as well, as usual. So let's examine how we would use a VPC endpoint in this scenario. Here we see an EC2 instance that's created in a private subnet. So I've got an EC2 instance in the private subnet, but it needs to now communicate with resources that exist outside of the VPC. Those resources could include an S3 bucket or a DynamoDB table. So in order to communicate with those services outside the VPC, the traffic from the EC2 instance in a private network is going to need to traverse an internet gateway. So we're going to have either a NAT instance or a NAT gateway, creating the ability to communicate over the internet, and then the traffic is going to flow over the internet to that S3 bucket or that DynamoDB table. So this is what we're trying to get away from. I don't want my EC2 instances to have to send traffic over the internet in order to communicate with an S3 bucket or a DynamoDB table. A preferable approach would be, let's get rid of this NAT gateway or NAT instance, whatever it happened to be. Let's get rid of this internet gateway. And as a matter of fact, let's just remove the public subnet entirely. And so now I've got an EC2 instance on a private network, and I want to allow it to communicate with S3. So what does my route table look like in this scenario? Well, what I'm going to do is create a VPC endpoint, and I'll specify the service that I'll connect to, and I'll attach it to my VPC. And then I'll simply add a route to the route table pointing to that VPC gateway. And the route can look different depending on how you set it up. So here we are in the AWS documentation looking at the VPC user guide. And specifically, we're looking at the Gateway VPC Endpoints section. But basically, here's an example of a route table for a private subnet. And we can modify this route table to point certain traffic, for example, S3 traffic, over the VPC endpoint. And here in the documentation, we can see how that happens. When you create or modify an endpoint, the route tables are used to access that endpoint, and a route is automatically added to each of the route tables with a destination that specifies the prefix list of the service. So that's what this PL destination here is. It's a prefix list specifying basically all of S3 for this example. Right? And it represents the range of the public IP addresses used by S3. So all of the instances in this particular subnet will utilize this route because this route is going to be more specific. Even if we did have a default route for 0.0.0.0/0, this route is more specific. Therefore, it will take precedence over any default route. And you can find more information about the routing rules. Here we see an example of a route table with a default route. But again, it's got this prefix list specifically for S3. And therefore, that route is more specific than the default route. So that is the route that will be used for S3. S3 traffic will flow securely over that VPC endpoint. And as you read through this, you can find a couple other scenarios for routing to a VPC endpoint. So let's take a look at another one of these scenarios. So here again is our VPC, and we're going to focus on the public subnet for a moment and an EC2 instance that we've created in that public subnet. And let's say, for example, in this scenario, we want to allow the EC2 instances in the public subnet to access S3 over the internet. So how do we make this happen? We create our internet gateway, we associate it with our VPC, and then we set up our route table with a default route to the internet gateway. So for this particular EC2 instance, it exists in a public subnet. That public subnet has its own route table. And if we just simply create a default route to the internet gateway, then the traffic for that particular EC2 instance to S3 will flow over the internet. As compared to my private network, where I've established a VPC endpoint and I've configured my route table specifically with a prefix list for S3 to send that traffic through the VPC endpoint. And then I could also have a default route for that private network pointing to a NAT gateway in the public subnet. So let's just go through a few final VPC endpoint characteristics. A VPC endpoint is local to one particular region, cannot be reached from another region. It's also bound to a single VPC. So a VPC endpoint cannot be shared by multiple VPCs. But we can have multiple VPC endpoints within the same VPC based on route tables. So I could have a VPC endpoint for S3 and specify a prefix list entry in the route table for that. And I can have a different endpoint for DynamoDB with a different entry in the route table. VPC endpoints cannot be accessed over a VPC peering connection. Now, just to make this completely clear, we're talking about gateway type endpoints. We're not talking about private link or interface type endpoints here. We are specifically talking about gateway type endpoints. So for more information on that particular scenario, here we are on the AWS website looking at the VPC peering documentation. And you can see here it's going to show us unsupported VPC peering connections. And some of these we're already familiar with, like transitive pairing and overlapping address ranges. But down here at the bottom, you can see edge-to-edge routing using a VPC gateway endpoint. And so in this scenario, we've got a VPC endpoint attached to VPC-A. VPC-B is a peer with VPC-A. That does not allow VPC-B to use the VPC gateway type endpoint that belongs to VPC-A. So you can't directly access S3 from VPC-B using the VPC endpoint of VPC-A. Now, another important consideration when we're thinking about these gateway type VPC endpoints is what if I have an on-premises data center and I want to securely access a service like S3 through that VPC endpoint. Well, here we see an AWS document that breaks this process down. And we can see here we have our corporate data center. And within that corporate data center, I've got systems that are issuing S3 requests. And so as those S3 requests are being initiated, the local corporate DNS is going to be utilized to provide the destination that those requests should be sent to. So we're going to have to do some modification of our corporate DNS here. But what we want to do is direct those S3 GET requests over our VPN connection here. And we're directing them into this VPC that we have a VPN connection to. And that VPC has a VPC endpoint for S3. And so you can see here as these requests are coming in, they're hitting an elastic load balancer, which is distributing those requests across a proxy farm. The proxy farm has access to this VPC endpoint because the proxy farm is just essentially EC2 instances located inside of my VPC. So what's the benefit to this approach? Well, now, when an on-premises machine issues an S3 GET request, it's never flowing directly over the internet. It's always hitting this VPN connection here, and it's being properly secured to the virtual private gateway in my AWS VPC. And then from there, it's being redirected over the private AWS network using this VPC endpoint. So that's another benefit that we can potentially get out of utilizing these gateway type endpoints, is to further secure traffic from my on-premises environment to AWS resources like S3 and DynamoDB.